Hey everyone, so today we'll be looking at an analytical geometry problem. As you can see, let's read what it says. It says in the diagram, the circle centered at M, coordinates 2, 1, radius km is produced to L, a point outside the circle, such that KML is parallel to the y-axis. LTP is a tangent to the circle at T with coordinates negative 2b. S coordinates negative 4.5 and negative 6 is the midpoint of PK. Right, let me just move this so that we can have space for working. And this is the first question. And let's have the diagram over here. So the first question says, given that the radius of the circle is 5 units, show that B is equals to 4. So this is how the solution goes. We first write down the equation of the circle. So the circle centered at M will have x minus x coordinate of M all squared plus y minus y coordinate of M all squared equals to r squared. So they've given us what r is, so we'll be able to substitute r for 5. And the coordinates of M are there in the diagram, as you can see, are 2 and 1. Then let's do that. So we end up with x minus 2 all squared plus y minus 1 all squared equals to 5 squared. 5 squared is 25. Then we will substitute the coordinates of t, since it's on the circumference of the circle, for x and y. So we end up with minus 2 all squared plus 1b minus 1 all squared equals 25. Then we simplify this to get this. Minus 2 is minus 4. Then squaring that, we get 16. We take 16 to the other side. Then 25 minus 16 gives us 9. Then to get rid of the square here, we will root both sides, square root both sides. And then we have a plus or minus, since it's possible to get two values of b there. Then we get b minus 1 equals 3, or b minus 1 equals negative 3. We take 1 to the other side. B equals 1 plus 3, or b equals to 1 minus 3. Then b becomes 4 or minus 2. Then we look at the position of t. The point t is above the x-axis, so which means we'll accept the positive value of b and reject the negative value of b. So yeah, that's how the first one is done. Let's look at the next one. The next one wants the coordinates of k. So for the coordinates of k, we will first say that the x coordinate of m and the x coordinate of k are the same, since mk is parallel to the y-axis. Then the y coordinate of m will be 5 more than the y coordinate of k, because mk is a radius and it has 5 units. So this ends up giving us k of 2 and negative 4. That one was simple, it's 2 marks. Next, they want the equation of the line LPT or LTP in the form y equals mx plus c. Then we start by looking for the gradient of Tm, which is the radius of the circle. We do this because we know that the radius is perpendicular to the tangent at the point of contact. So at T, there's a 90-degree. So we're going to use the property of perpendicular lines to find the gradient of LTP, and then use that gradient along with the point T's coordinates to get the equation. So let's see. Substituting, then simplifying, we end up with gradient of Tm is minus 3 over 4. Now, that property of perpendicular lines says we just flip the fraction and multiply it by -1. So that is what we get for the other gradient. Now we go to the straight line. In the y equals mx plus c equation, we'll substitute the point T and the gradient that we just found. And we will simplify, we get that, take the minus 8 over 3 to the other side, becomes positive. Then the 4 I've changed to 12 over 3, so that they are fractions of common denominators. And we add them, we get c equals to 20 over 3. The equation then becomes 4 over 3x plus 20 over 3. Okay. Next one. The area of triangle LPK. Now, with this one, we are going to look at the simplest way to do it. In my opinion, I think the simplest way is for us to use LK as the base and then use the perpendicular distance between P and K as the height of the triangle. So imagine the triangle has been rotated 90 degrees clockwise. Then LK will be the base, and then the distance from the base that we've chosen LK to the highest point of the triangle P will be the vertical distance between P and K. So we will do substitute x coordinate of L into the equation that we just found in the previous question, and then we will look for the coordinates of P of L. So we get this, and then when we simplify, we get 8 over 3 plus 20 over 3, which is 28 over 3. So it means the coordinates of L are 2 and 28 over 3. Now we only needed the y coordinate because the length of LK, we simply subtract the y coordinate of P with the y coordinate of K. Then we get 40 over 3 units. So this is the base that we are choosing for the triangle. Let's put it on the side. And now we're going to look for the distance, the perpendicular distance between P and K. So S is the midpoint of PK. This means that the transformation or the movement, the horizontal movement, looking at only the horizontal movement of the point from point K to point S will be the same as point S to P. So we see that from K to S, we subtracted minus 6.5 to get minus 4.5. It means we must do the same on S to get P. Then S's coordinate is -4.5, and we subtract -6.5 to get xp. This means xp is -11. Now the height of the triangle is that -11 subtracted from 2, the x value of k. Then that gives us 13. And then now we can calculate the area because we have the height and the base. And this plays out to be 260 over 3 square units, which is approximately 86.67 square units. Right. Next question. Another circle with equation x minus 2 squared plus y minus n squared equals 25 is drawn. Determine with the explanation the values of values of n for the two circles to touch each other externally. Okay, so this is my explanation. So this new circle will have the same x coordinate, since we have that x minus 2 squared in the equation, the same as the original circle. They will share the same x coordinate. Then the y coordinate, on the other hand, is the one that is varying or changing. So the circles to touch, the circles would have to be the sum of the radii distance apart. So that is 5 from here and 5 from the original. So that is 10 units. That's where we get the 10. So n must therefore be 11 or -9. And then that is how we end this question. But to show this, to show what I've explained here, I have drawn this diagram on GeoGebra so that it can be shown visually or graphically. So let's go to GeoGebra and see what happens. On GeoGebra, I've already drawn the picture. You can see they are the same. And let me just hide this for now. Then the red circle is the new circle that they've been talking about. As you can see, I have made its center n, and n has the coordinates. X value is the same as this one here, m, which is 2, and then the y coordinate is n, and it is varying. So when it is varying, when it is changing, this is how it is moving. So we want to know when exactly do the circles touch externally, which value of n or must it have. So I can press here to animate so that you can see how smoothly GeoGebra helps to visualize these things. So as you can see, the circle going up and down like that, there's one point where the circles will touch from the outside. That is the point where we want to know what the center y coordinate will be. And again, it happens this side here. So let me just pause it, and then we can do it manually and move it and see what value actually makes the circle touches. So the n value is over here, and I set it to be 11. So let's take it to 11. 11 exactly, and then indeed our two circles are touching externally. So that means our n equals to 11 is correct. Then let's go to the other side. I said it must be -9. So we are at -9, and again we have the circles touching at the bottom. So this shows that this is correct, and I will stop the video here. Please subscribe and share my video, um, write comments, and I will try to respond to them, and I will see you in the next video. Thanks very much.